So we'll go ahead and kick off now. Welcome, everybody. Thank you so much for joining us today to talk about RAG, one of the most misunderstood and often talked about things in AI today, aka ChatGPT for your data. Everybody wants to build it. How do we build it? What's going on exactly? We're going to find out today. And we're going to do it open source. We're going to do it open source. So we're going to add an additional layer of complexity. Tomorrow, we're going to take it to the next level, and we're going to say, okay, we built end-to-end RAG. Now, how are we going to take this and how are we going to instrument it with all of the metrics that we need, with all of the things that we want to measure so we can actually improve it using things like advanced R methods and using some of the latest and greatest frameworks and tools. First off, just shout out to LangChain. Happy birthday, LangChain. So that's pretty cool. 1 year, it's 1 year old. And that's pretty cool because that's how crazy and how fast this thing's moving. LangChain is a year old, so it's about time if you learn it. It's a great workshop to start learning it. ChatGPT, Chativersary is coming up in about a month. So the space is just crazy. And if you're building RAG systems a year in, you're in the right place at the right time. One of the things we like to do at AI Makerspace, or AIM, is we like to go ahead and align our aims for the day. So for this session, what you're going to walk away with today is you're going to walk away with an understanding of open source RAG systems, full stop. You're also going to understand how easy it is to build with the latest and greatest. And you say, well, what's the best model that's open source? Everybody's like, well, it's Llama 2. We're not really going to talk about why. We're just going to pick it up. We're going to use it. We'll talk a little bit. And then what's the best vector store? It's like, I don't know, maybe the guys that got the most money. We'll learn a little bit more about Pinecone, and we'll learn a little bit more about choosing vector stores as we go. But Pinecone is pretty good. So today we're going to talk what is RAG anyways. We're going to sort of break it down into two core pieces. We're going to talk about RAG being a combination of dense vector search or dense vector retrieval and in-context learning. These are core ideas that sound really fancy, but you shouldn't say them to people. We can say them amongst ourselves as kind of nerding out here. Just use regular words for most people. And we're going to sort of break these down into the regular words. You can't really say RAG to people. You can't really say dense vector search. You can't really say in-context learning. But you can say a lot of things that will make it very, very clear what's going on. And hopefully, we'll give you some of those words today. We'll talk about LangChain. We'll talk about Pinecone. We will talk about all of that. First, just sort of like at a high level, I think Andrew Ng put this out early on a few months ago, maybe 2 months ago. And he said, when you're building stuff, this is what you should do in general. And I think there's this real dichotomy. I just want to sort of address the elephant in the room. Which one should I do? RAG or fine tuning? Well, it's not an either or. That's not not the right question. Where do I even begin if you're asking me that question? We're not going to talk much about that today, other than this very, very high level introduction. But first of all, you should always get as far as you can through prompt engineering. We're not really going to talk about prompt engineering except at a very basic level today. Once you do that, now you build a question answering system, AKA in nerd speak, RAG. Okay, you're just building a question answering system against documents, against data that you can pull references from. So that question answering system is number 2. This is the purpose of the day. We don't want our LLMs to be machines that can't tell us why they answered the question the way that they did. This is the idea of a RAG question answering system. Because an LLM is a question answering system, right? It'll answer your question. It's just, I don't know if I want to take that answer. So what we want to do is we want to build this thing. Let's stop calling it RAG for a minute. Let's just call it a question answering thing. We can call it a Retrieval Augmented question answering system, and this is something that we do in our courses, or RAQA, RAQA. So we're going to rock out today a little bit, but first we need to do some pregame stuff, and I'm going to have Chris come up here right now. So get your laptops out if you don't have them out. We're going to get you downloading Llama 2, the model that you need today, first, before we dig into a bunch more concepts, and we're going to get you just doing a couple little boilerplate things. In order to do this, you might want to go to bit.ly/aimrag. And I didn't put it where I should have put it on the slide. So let me go find this for you. Go to this link. Go to this link, bit.ly/aimrag. And Chris, come on up. And we're going to get good at this quick swap, just like we're screen sharing on Zoom. bit.ly/aimrag.
What's up? So it is bit.ly/all caps aimrag. And you should see a Colab notebook. This is the notebook we're going to be following today. It's going to take us kind of from the the basics all the way to implementing a simple RAG system using LangChain. So this is what we're going to be using as kind of our walkthrough. Now, in order to get started, we want to get you guys downloading Llama 2 now instead of later. There are two things you want to make sure of, though. Number one, we will need a GPU. So you are going to have to make sure that you get a GPU instance. The free version of the GPU instance is fine, so you can use the T4. You're going to be able to follow along with the whole thing. If you have Pro, you can use whatever you want, but the T4 will do. Just have to make sure that you have a GPU instance. After that, we're going to be using this new research Llama 2 7B chat model. This is because the Llama 2 model requires you to have access or have the weights, which you have to request, which might take some time. And this is going to let us use this right out of the box. We have to set this boilerplate sample just so we don't run into any errors. Just a thing about Colab. Next, we're going to grab some dependencies that we're going to be using today. We're not going to be talking about them too much specifically, but they are integral to the process of running this open source model. We have our transformers library. Since we're using their transformers model, we have our accelerate library and our bits and bytes library. This is what's going to let us run a 7 billion parameter large language model in our free Colab notebook instance. We're going to need to set up a pipeline in order to do this. Now, LangChain is very well integrated with the Hugging Face Transformers pipeline ecosystem, so as long as you can get whatever you're trying to use into a pipeline with the task text generation, you're going to have a great time integrating that open source model with LangChain. There are a lot of optimizations that you can do, but for now, we're just going to talk about simple pipeline, which we can set up as follows. We're going to pass our model ID, which is our new research, Llama 2 7B chat HF. You'll notice we're using the chat model. It does the instruction following a little bit better. It is not an instruct-tuned model specifically, so the actual performance is going to be surprising when you see how well it actually works on this task, because it's not custom built for this task at all. It's just a chat model, but it does a great job. Thanks, Llama. And we're going to just make sure that we're putting our model on the right device, so we have this device selector to do that. We're going to really exploit all of Tim Detmer's hard work in order to run this in the free Colab instance. So we're going to load our model in 4-bit quantization. We're going to use his NF4 quantization data type, and we're going to use the double quantization where we quantize the quantization constants. But we're going to leave our compute D type in bfloat 16. So the way this works is we store the model in as small a format as we can, and as we compute with it, we're going to blow it up to a higher information capacity data type, so bfloat 16. That's all we really need to do. The next thing we got to load up the model. We're going to use auto model for causal LM. Thanks, Transformers, for making it easy. We're going to pass our model ID, trust remote code. This is because a lot of the newer models have specific code implementations, and if you don't trust it, then you can't download the model. And then we'll pass in our bits and bytes config, and device map auto here is just going to prefer to store our model on the GPU, but if it runs out of room, it can overflow to the CPU. It shouldn't happen, and it won't happen on the T4, which is the smallest available GPU instance. And then we can check out the actual model. Looks great. Just a ton of decoder layers. Nice, huge, let's go. We're going to also download our tokenizer. We just grabbed this straight from the same repo on Hugging Face. it's custom built for the model. There you go. We got to be able to tokenize. And then we're going to set up some stopping criteria. So this is not about the RAG system yet. This is just about the model. But this model tends to run on. It's very verbose. It likes to chat. And so we want to stop it from doing that, right? We don't really want that chat style output for our RAG application. So we're going to stop it at these token sequences. We do that using the stop on tokens custom stopping criteria we build. This is just boilerplate. All it's saying is that when it sees these tokens, we should get the heck out of there. Now that we have kind of our model, our tokenizer, our stopping criteria, we're ready to set up our pipeline. And our pipeline is going to be as simple as passing in our model, our tokenizer. We need the full text because LangChain needs it. Without this, LangChain can't do its job. So this is just what you got to do. Of course, we're going to be generating text. That's the whole thing. We're going to pass our stopping criteria. We don't want our model to be creative, so we're going to get a very low temperature. When we're talking about RAG, oftentimes we're talking about distilling information from a bunch of contexts into a truthful answer, and so we don't want the model expressing its creativity when it's doing that process, at least for the application of truthful question answering. Max new tokens is just how many tokens are we going to generate. You can put this as any number. We put it as 256 just for the purposes of the demo. You're going to choose this based off your use case. And then our repetition penalty, we're going to penalize the model for generating repeated token sequences so that it doesn't become repetitive. It's an unsatisfying experience if we get an answer and it's just the same thing over and over again. Our users won't like that, so we're going to penalize that from happening. Once you've done this, and you shouldn't be done now, it's going to take a while to download those model weights, you can go ahead and test out the pipeline by passing it in a question and then looking at the text that it generates. It's going to take you a while to download the weights, so just let that happen while we continue on with the presentation with Greg. Screen share.
Awesome, Chris. Screen share. Ooh, the quick connect. Need the quick connect. So in case you missed that or you came in while Chris was talking, what we're doing is we are building this. So go to bit.ly.aimrag to get this Google Colab, and the idea is it's going to take a while to download the model weights, so start doing that now. We don't want you guys to get into the weeds and then not be able to sort of do what you need to do. You may have noticed that there was quite a bit of setup, but it's all there for you. It's all there. This is just sort of click run, click play in Google Colab. So if you feel comfortable clicking play, you should be able to follow along the rest of the day. The thing is we're stacking a lot of complex things on top of each other today, and so we need to kind of get started. We're going to crawl, walk, run as best we can, but that could have been easily 90 minutes there just walking through all of those things. But we've got some work to do today. That was our pregame. So let's talk about our data. What are we looking at? What are we trying to do? Well, we're going to use sort of just a fun example here. We're going to use Hitchhiker's Guide to the Galaxy, an absolute classic, right? Legendary classic. It's got 446,000 words. This breaks down into somewhere around 100,000 tokens, and we're going to use a chunk size when we do stuff or when you ask questions against this thing of about 200 tokens. And the idea is, yes, you can do stuff within this Google Colab context, and yes, you should, as a developer, be developing within the right context. Am I getting double mic action going? Is this like extra loud? I'm not sure. But the bit.ly is one way to do it. Another way to do it, if you're sort of newer to this, is to just go ahead and you can actually leverage a tool that's more of a low-code, no-code setup. And this is one that we like to show. It's called Chat with Your PDF. And this tool is one that you can find on AI Makerspace's Hugging Face account. And this is a internet or Hugging Face thing happening right now. So not sure what's going on there. So you can easily, super easily, live demo gods not being kind to us right now, chat with a PDF. And we're going to go ahead and move on from that because Hugging Face is not being cooperative. Sometimes it does that. We did that during a demo day recently we had with our students, and that was a kind of a disaster. So they had to build locally and present that. But we're going to keep it moving. Why are we doing RAG? Well, the problem is that every time you ask an LLM a question, it will give you one. And this is the big problem that a lot of enterprise has. I can't trust it, right? And it's like, well, you give me these responses, but they're not true. But what does true mean? Well, in today's world of fake news, true means like, can you fact check it? Can you give me a reference? As long as you give me a reference, it's like, fine, all right, cool. At least you can tell me where it came from. And that's really the best we can do as people and as a result, as AI systems. And so this idea of fact checking is very, very important. And this lies at the core of what we're doing with RAG. Because when we do RAG, we're doing retrieval, where we're finding references. We're doing augmentation, where we're taking those references and shoving them into the prompt. We're trying to order rank them sometimes. We're trying to be a little bit sophisticated about the way we're augmenting the prompt. And then we're actually doing our generation at the end, which is just put it all in to the LLM and then get a generated thing out. And that's what we're doing. It's Gen AI. So the idea is taking like the facts, shoving them all into the context window, and then the idea is it improves the generation. Or at least, if it doesn't improve the generation, then you know where it came from. And it's like, okay, fine. Yeah.
I just want to tell you, you just gave the best way of explaining that.
Thank you.
So intuitive. I appreciate that.
Thank you. Yeah, I mean, it's a real big problem, right? This idea of getting things you can't believe out of LLMs. And this is really also very, very useful in domains where you've got really crazy words that people use, right? You go to the doctor, they're talking to each other, it's like, what are they talking about? Or you talk to a lawyer, it's like, forget it, right? Or you go have to deal with acronym soup, like in the city built around an Air Force base. I live in Dayton, Ohio. This is a huge, huge problem. And so these LLMs, they weren't trained on data that's specific to these domains. They weren't trained on stuff that, it would know these words. And if you ask GPT-4 about LangChain or llama index, it doesn't know because it was trained only up to 2021, presumably, GPT-4. And so this idea of getting this stuff right, the easiest way to do this, again, is not fine-tuning. Step one, prompt engineering. Tell it a couple things. Step two, use RAG, okay? Shove it some documents. Be like, okay, can you figure it out from this? The context in the docs. And so this is sort of the big idea. RAG is broken down into two things. Dense vector retrieval and in-context learning, the R and the AG. This is the core of what you're going to take away from today. You're also going to take away a bunch of great code in an awesome note blog that Chris has created for you, bit.ly/aimrag, if you have not downloaded it yet. These two pieces are going to kind of guide our investigation of this. So let's take a look at this as a system overview. Let's take a look at the diagram perspective, the infra diagram. Everybody loves these, right? So what you want to do is you want to ask a question. You want to query something. And that query is then sent to an embedding model. The embedding model takes that query, it takes those numbers, it turns them into, or it takes those words, it turns them into numbers, creates a vector. That vector is then sent into a vector database that has all of your stuff in it. It has all of your data. It has your PDFs, it has your this, your that. And you can get very, very complicated, very, very crazy. Mild to wild, these things go, vector DBs. But they're all vectors. And so there's a bunch of lists of numbers. And so you look for numbers that are like the numbers from your question. And you're like, can I find similar vectors? And you do a little similarity, just a little classic cosine similarity. Meanwhile, you get your LLM set up like we just did, like Llama 2, and then you're going and you're setting up the prompt template. And the prompt template here, before you shove in all the stuff you get out of your vector database, you're going to actually set it up. You're going to say, use the provided context to answer the user's query. You may not answer the user's query unless there is specific context in the following text. If you do not know the answer, you AI system, or cannot answer, please respond with, I don't know. Please do not give me an answer, right? You have to treat this thing like a child because it very much is. It has much learning to do. We have to train it to do exactly what we want it to do. So we take our query, now we need the context, and we're set up with the template. The context, of course, comes from the similarity search that goes on within the vector database related to the query. So we've got now the context, reference 1, 2, 3, 4, 10, 100. Maybe we do some re-ranking. Maybe we do some advanced stuff. Maybe we take vectors. Maybe we use some metadata within the indexing. Maybe we have some qualitative and some quantitative data. We can get real wild with this. But at the end of the day, you're shoving these references into the prompt. All of this gets, at the end, we haven't even done the LLM thing yet. Not until the very, very end, we do our generation. So most people, they sit right here and they put stuff in here. That's it, right? What we're trying to do with RAG is we're trying to develop a system that's going to be much, much smarter. Is it really smarter? It's like, well, it's using much better data. Yeah.
So is this prompt engineering or is this fine-tuning?
Did you hear the intro we started with? I would say it's neither. This is prompt engineering. We haven't done fine-tuning at all. There's no fine-tuning whatsoever here. And fine-tuning is not the answer to your problems. Let me just, and we can nerd out on that later, but that's a tad bit beyond the scope of what we're going to talk about today. Photos, yeah, that's harder. I would not put that directly into this framework in your mind. Although you could imagine a more complex setup here that could deal with data of different types and of different sorts. Llama Index is coming out with great tools on this. There's a lot of people who want to solve the problem because a lot of people will have, hey, I have a technical manual, and it has tables and charts, and it has pictures and words. You have to get more sophisticated here. It can be done, but there's a lot more engineering work to do. But like lawyers are in a great spot today, although none of them care to do this, because they don't have any pictures in their freaking documents. It's just words for days, right? So think about words for days documents as a first cut. All right, so how do we orchestrate that entire thing? Well, what we're going to do first is we're going to do it in a sort of Pythonic, very naive way. And then we're going to add LangChain in. Because we're going to do it the hard way, then we're going to learn the easy way. And in order to sort of understand why LangChain exists, because it's like happy birthday LangChain, and that's part of the reason you probably came to this, I want to kind of give you the old statement from a few months ago that they used to make, and then give you the new one that they're making on their site. And they're doing great things, and they're one of the major players in the space. The idea is the LLM by itself isn't the answer, as we just saw in the diagram. The LLM by itself is just going to be the thing at the very end of this system. The power comes when you combine it with other cool stuff and other data. And this is what they said early on. This was like top level line one of their docs early on. Top level line one of their docs now. They have some of this new fancy language because they're very much growing up. They got their Series A 6 months ago. And the idea is they want to be data aware and agentic. So they're kind of abstracting a little bit with their language. What does that even mean? It's like, well, you want to connect it to data. The data-centric paradigm has not gone away just because we use LLMs. And we want to also be able to have it pick and choose tools from its tool belt of different sorts and types. And this is going to make for very complex things. We will not be talking about agents today, although we know everybody does love agents. The chain is the fundamental abstraction. There's nothing crazy here. There's nothing, you can do this naively without LangChain. You're just connecting stuff to other stuff. You're chaining stuff together. It's very easy to do. It's some glue that connects, for example, a raw source document to doing some chunking, putting it through an embedding model, and building a vector database. These steps are easier with LangChain. And this is like one chain, the data indexing chain. So that's the sort of fundamental abstraction that they really add for us, is the chain. And then they've got a few pieces of the puzzle that they want to kind of go into. Number one is the model. And generally when we teach this, we're always teaching OpenAI first. We're not teaching OpenAI today because open source for the win. But the reason we teach OpenAI first is because to set up that prompt template, to say, here's the system level context message, here's the user input, and then we're not really leveraging this assistant message in the way you might in a prompt engineering context. That they kind of started the game, and they said, we're going to come up with a system user assistant. And then LangChain comes in, and they say, well, yeah, that's pretty good, but actually we like these words better. And I like these words better too, and I think Chris likes these words better too. They make more sense. This is sort of the high level. You want to provide that high level context. You want to give it a role, a persona, a place to stand. You want to give it an emotion, a flavor to sort of give your output exactly what you want. That system level context is also weighted more heavily in many LLMs. The user is like, that's just you using it, or your user using it. That's just you as a developer. And then the AI message is like, you can act like the AI here, which is useful, especially if you want to do one-shot, two-shot, few-shot learning, which we'll talk a little bit about in a second. And so this helps us set up our prompts. This is where in-context learning comes in. This is sort of a fancy word. And I don't know why. It took me so long to understand this. What is this even talking about? This was like the GPT-3 paper. Few-shot learners, right? They introduced this idea of in-context learning. It's like, what does it mean? Well, you're just putting stuff in the context window, and you're teaching it stuff. When we talk about prompt engineering, and this is not a prompt engineering 101 workshop, but we always want to give super duper clear and specific instructions. Instructions. If there's one thing to remember about prompting, it's instructions. You're training the child. You need to give the child instructions. Giving it a place to stand. Telling it how it feels. Telling it the kind of things you want to hear from it. Tell it the way it's good at interacting with the user. And then input, one-shot, two-shot, few-shot learning, chain of thought reasoning. You can go into self-refinement, self-assessment, and we'll do some of that over the next day or so as we talk about evaluation. But the final thing is the output format. And just as a real quick overview, I'm going to give you the canonical examples of both few-shot and chain of thought learning. This is the paper. This is the example. A watpu is a small furry animal native to Tanzania. Watpu is not a word, right? You're teaching it a word. An example of a sentence that uses the word watpu is, we were traveling in Africa and we saw these very cute watpus. To do a fardoddle means to jump up and down really fast. An example of a sentence that uses the word fardoddle is, so what did we do? We gave it input, output, input. And so what we can do in a question answering context is we can give it example question, example answer, actual question, answer. Why would we want to do that? Well, we're giving it examples. Now, we can do that for a long time in QA systems. We can do that all the way until we run out of context in the context window. And in fact, what we're doing in this case, we're giving it input, output, input, output. So we're teaching it, we're telling it to learn from this context, in context learning. Take it to the next level. The canonical example, chain of thought reasoning, the paper. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? The answer is 11. No, Timmy, the answer is not 11. Tell me why the answer is 11. It's like if you're okay with your model answering like that, you're going to say, well, how'd you get that? How'd you get that, man? Right? Can you walk me through how you got 11? Right? And if he's able to walk you through how he got 11, he might say something like this. If he's real sharp, like front of the classroom type Timmy, he might say, well, Roger started with 5 tennis balls, 2 cans of tennis balls each. That's 6 more tennis balls, and 5 plus 6 is 11. If you make your models do this, they get smarter. They get better. This is very well studied. This is a way to add a little bit to your in-context learning. If you don't get the answer you want and you don't know how to provide this, there's cool ways like, hey, can you tell me how you thought through that step by step that you can get what you need? So this is a way to take in-context learning to the next level. But this is just basic prompt engineering. Why does it matter? Because we're abstracting beyond prompt engineering when we build RAG systems. So that's going to allow us to do the chat model syntax that we need within LangChain according to the OpenAI default stuff that really set the tone for the industry and formed kind of the way that we interact with models using best practices of prompt engineering. So this gets us to just, we got to put a template together. We already talked about it. You guys already understand this. It's just boilerplate code. Get ready for all the references I'm about to shove into the context window that you're about to learn from in context learning. And of course, we already talked about chains. So what's funny is, once you know about the chat model and you know about the template, you basically built your first chain with one line of code. You built your first LLM chain. This is a big deal for us today at Makerspace. We love when people build their first chain. And when people build their first LLM, how many LLMs deep are you is a question we'll ask people in our community a lot. And this is your first one. So congratulations if you haven't built one today. Once you run this cell, you're in. This is where Chris takes over, and he's going to walk through exactly what this without LangChain setup looks like, because we're going to do it the naive and Pythonic and hard way first before we take all these great abstractions we just learned and put them to the test. Chris, over to you. Screen share.
All right, so we're going to talk about how to build this first in a more traditional way, so we can look at what each of these components looks like. There are a lot of pieces to the RAG puzzle, and it might be good to get our eyes on what each of those pieces look like. We are going to start with LangChain, though, because it's awesome, and we need something to kind of interact with the model, right? And the easiest way to interact with the model is going to be through LangChain. It's built to do that. It's great, and we get to build our first chain right off the hop. So we talked about it before, but we created a Hugging Face pipeline for our model, which is the transformers-based pipeline, but we need to get that into a format that LangChain understands. So we're going to go ahead and grab LangChain as our dependency, and then we will set up our LangChain.LLMs Hugging Face pipeline. That's as easy as it is. You just pass it the pipeline that you created, and you're away to the races. So the idea here is that we wrap our Hugging Face pipeline in this LangChain interface so we can use it with the rest of the library, no probs. And you can see here, if we take our LLM and we give it a prompt, we get a response. And this is just the raw response from Llama 2 7B chat. That's it. The idea here is that now we're able to interact with our model through LangChain. So let's build our first chain. But in order to do that, we're going to need a prompt template, just as Greg was talking about. So in this example, we're going to create a chat prompt template. A lot of different, you have your chat style models or your kind of DaVinci 03 style models, which are just going to be, taking in one input. They don't really care about the system message or anything like that. But Llama 2 does care. It does have the ability to respond to the system message. So we're going to take advantage of that today. We have our system template, which is this, we saw an example from one of our, the people in one of our programs. You're a legendary and mythical wizard. You speak in riddles and make obscure and the whole thing, right? So the idea is it's a very silly prompt, but it'll be noticeable if it works, right? We should be able to see this influence our LLM's outputs. Once we have our system template, we're going to pass in our human template. So this is like what the human's going to say, right? This is the input to the model. This is what your users are going to write in. And you'll notice that it's just this placeholder of content. That's because we're going to set this up when the user gives us their input, so we can make this dynamic. We don't have to hard code the prompt in. That would be absurd. We can organize this into a chat prompt template from messages. The idea is each of these is an independent message. And we're going to set it up as a chat prompt. This is going to handle sending that information to our LLM and putting it into the correct format based on which of the models you're using. Hugging Face has very handily created an object that will handle the prompt format for us, so we don't even have to think about that, right? You might have seen in the past, like Llama 2 has this, angle bracket, space, inst, no more. LangChain and Hugging Face handle that for us now, and that's great. We're going to set up our first chain. LangChain's done a lot of work recently, right? It's 1 year old, happy birthday, and everything like that. Making chains became a lot more clear and readable when they introduced what's called the LangChain expression language. And we're going to see our first instance of that, and you'll see how straightforward it is to understand, right? You might ask, well, why don't we do it the old way? Why do we want to do it with this expression language? Well, number one, it's easier to read, right? You can follow through the flow of the chain very easily. Number two, it's got everything we want baked into it, right? So it has this async and streaming support out of the box. We don't have to worry about that. It's got the fallbacks, are very easy to implement in the chains. They used to be a little bit difficult to kind of connect the dots. And it's got that built-in parallelism where it can be taken advantage of. Another option, which we'll talk about tomorrow, is that it integrates very nicely with LangChain's evaluation framework, Langsmith. But for right now, we'll just talk about the idea of these chains. So we have these two core objects. We have our chat prompt, which is that system and human prompt, and then we have our LLM, which is, of course, our Llama 2 model. And to create our chain, this is it. This is the whole thing. We'd say chat prompt, pipe, LLM. And it works as you might expect, right? We have the, read it left to right. We have our chat prompt, which is piped into our LLM, which returns a response. And that's the whole thing. We, in the text here, go into a little bit more detail. The idea is that each of these objects has a specific input and output, and we just need to make sure that we line those inputs and outputs up, that we're passing in the expected output to the next object. But this is all we need to do, right? LangChain made it very simple. This is our first chain. And you can see when we invoke that chain, yeah, go ahead.
Is it the same like LLM chain?
It's the same as LLM chain. Precisely, yes. LLM chain and other chains might not have some of the features that we really want baked in, like that asynchronous or the ease of implementing different fallbacks. So this is why we have this new chain syntax. It's also just it makes sense, right? We go left to right, we're piping in. If you're familiar with CLI, the pipe should be a familiar operator.
This is the expression language.
Yes, that's correct. Yes, that idea of that pipe operator. And we'll see when we build our RAG, we can get a little bit fancier, but at the end of the day, we're just, we're piping text or data around. That's what LangChain helps us do. It helps us glue these parts together, and it helps orchestrate our data flowing through all of the core components we need it to. Yeah, so if you're using a toolkit like Langsmith, or if you're using a toolkit like, you can implement like any kind of error checking that you want in each of these chain sections, but through Langsmith, it's gonna tell you exactly which part of the chain failed. It's the same thing in weights and biases, which is like a stand-in for Langsmith that you can use that doesn't require the beta access. But the idea is, this is all set up under the hood to be well traced out, so that we can have an idea of which component failed, when, and why. Great question, though. And all we got to do is invoke it, right? We have our content. That was the placeholder we had earlier, and then we just say hello world, because that's, it's software. We got to say hello world, right? And then we get this text back with wizard. A curious soul has entered the realm of existence. The idea is that it's clearly taking into account our system prompt. It is talking like a wizard, and it emulates this conversation. Again, it's not the behavior that we would desire, so when we move forward, we're gonna get it fixed up a little bit. So we prompt it with a question, right? Could I please have some advice on how to become a better Python programmer? We get this whole rant from this wizard talking about all the things we can do. And that's it for the LLM portion, right? That's all we got to do. That's our first chain. So now we can interact with the LLM, and we're going to move on to, how do we take that and then turn that into a RAG system? So we're going to start with the most naive version of RAG, which is just you add the context, right? I mean, if you have a paragraph that you know is about a topic you want to ask questions to, you can just put that in as context, right? So let's just see that. We'll build another chat model chain. So this is going to be our chat chain. Same thing that we did before, except we got rid of all that wizard stuff, and we're just talking about you are a helpful assistant. It's a prompt that does a lot more work than you would think, right? Without this, you might get, yeah, what's going on?
When you did the prompt, you saw a response that had the human colon and some other text.
Yes, it did.
Wasn't that a stop ID we added?
It was, yes, but we hadn't yet reached the number of tokens that we wanted to generate. So yeah, that's right, yeah. It's not going to stop before we get to that token count with anything other than the model has a stop token. But Llama 2 is very chatty, so that's not going to happen. But great question. So in this case, we have our new Llama 2 model. The only thing that's different is that we have this you are a helpful assistant prompt instead of the wizard thing. And we ask it the question, right? Please define LangChain. And it gives us just a terrible answer, a confident terrible answer, right? It says, of course. LangChain is a term used in the field of natural language processing to refer to a sequence of words or phrases. It's just definitely wrong, right? It's immediately wrong, and it doesn't stop being wrong the whole time. And this is part of the issue, right? It's not that the model is confidently wrong, really here that's the issue. It's the model has no clue what we're talking about. It's never heard of LangChain, right? It's got no idea. This model was trained on data that did not include LangChain documentation, didn't include news articles about LangChain. The model's just got no idea what this whole LangChain thing's about, right? Again, LangChain's a year old. We can ask the same thing about, what is LangChain expression language? And again, we get a very confidently wrong answer. And that's great, but not what we want. So how do we fix that, right? What if we have the documentation about the LangChain expression language? Well, we could just give it as context the LangChain expression language documentation, right? And then we can ask it, based off that documentation, what's the answer to my question? Which is exactly what we do here. We have our human template, which has this placeholder for our context, our placeholder for our query or our question, and then we give it this prompt of use the provided context to answer the provided user query, only use the provided context. If you don't know the answer, respond with I don't know. Then we shove in all that context. This is all the documentation from the front page of the LCEL docs in LangChain. And then we can ask that same question, what is LangChain expression language? And just with this context, we get a great answer. This is exactly right. It refers to specifics in that documentation. Suddenly now our model knows all about LCEL, and it gives us a correct and good answer, right? And so this is that's the core idea of RAG. That's what the system is going to do for us, right? Obviously, we can just paste stuff in all we want, but that's not scalable. It doesn't work, for all cases. If we have millions of documents and you've already got to search for the document, you're not really saving time, right? So we're going to build a system that does that search part or retrieval part for us in the following cells. What's up?
So the word context, can you scroll up a little
You bet.
So which of these in the red is, so that one is a
Yes.
expression, that's a language. That is,
Yeah, this context.
just for example, create my context, go over.
Yeah, you can name it whatever you'd like. The idea is that this context block is going to be when we run this and we send this prompt to the LLM, this context placeholder is going to be replaced by this big chunk of text. And that's done in this section. When we invoke our chain, we have our query, and then we have our context in which we pass our context. So basically, it's like a fancy F string. A lot of people ask, isn't this just an F string? I mean, kind of, yeah.
They're just like variables.
Yeah, exactly. They're just placeholders. They get dot formatted, and away we go. What's up?
I was trying to LangChain in two different ways, like within the same context, like where like would the model automatically pick it up?
Definitely not. Yeah, if it doesn't have any understanding of that topic already, and you give it two conflicting answers, right? It's not literally a coin flip, right? Because we know it will behave in a certain way, but we don't have an assurance that it's going to pick the correct answer unless it already knows about that topic, or there's additional context that allows it to infer which answer is correct versus incorrect. So if you said like LangChain is a tool that creates rain or something like that, versus LangChain is a system that chains things together, the model's probably going to answer correctly. But if they're close, it's not something that's going to be able to do without us telling it. What's up?
How do you deal with the token limits in a prompt?
Yeah, that's a great question that we're going to get to in just about a second. Excellent question, though. What's up?
How is the formatting affecting the response? Because like I see the context have already new lines inside of it, but there is just one line between the end of context and the next one.
That's right. So we're relying on kind of these placeholder blocks. So these all caps colon sections of our prompt. It can be confusing to make sure that you have selected an instruction format. That's good. A lot of people do like the triple hash space query or triple hash space context. So I can just show you, right? So they'll do something like this to help disambiguate, but for the most part, the model's fairly good at picking up on what is the context versus what is the header for context. Great question, yeah.
But does that depend on the model you're using? That some models were trained with this specific format, so you should use this?
Yes, so the way that we're going to be doing this today, we're just going to leverage the in-context learning so that we're not exploiting a specific pattern, but you absolutely can fine-tune a model or use a prompt format that it's familiar with or was trained with in order to get better results. So some models, including Llama 2, though we're not going to go deep into it today, are trained with that instruction. In the case of Llama 2 chat, unfortunately, it's like the chat paradigm, right? So we have our different speakers. But for an instruction tune model, you would have like an instruction token sequence, then the context or whatever you want to call it, token sequence, and then the response token sequence. So they can be trained to follow that specific format, and that's a great reason why Greg earlier was mentioning, right? We're not talking about fine-tuning. Fine-tuning still has a place in RAG, so it's not like RAG and fine-tuning can't mix. It's just we're not really going to go into it today. But that's a great question. We can use the trained token sequences to provide our model with the correct information in a way that it expects. Just this model doesn't have that token sequence set up. And we don't want the chat paradigm, so we're not going to take advantage of that today. Moving on, one quick thing. So RAG is good at grounding the LLM, but it's not like perfect at it. As we heard, right, like with the question, what if we give it two answers and one is wrong? This is not a perfect system, but it does reduce hallucinations. It does improve the model's ability to answer correctly and factually. And a lot of that boils down to giving it an out, saying, if you don't know, just say you don't know. But for the most part, it's very helpful. Definitely not going to be the only solution to get rid of, whatever you're calling it, confabulations or hallucinations. Up to you, but it reduces, doesn't eliminate. Okay, so next up, we're gonna get the RAG part of RAG, right? So, or the R part of RAG. So we have the retrieval part coming up. The idea is exactly to a question we heard earlier, right? What if we just have too much context, right? So we, like the entire collection of Hitchhiker's Guides books is 750,000 tokens, right? That's too many. We have a context window of like 4,096 for Llama 2. There's no way we can fit that all in, right? So this is where we get to talk about something called chunking. Chunking is really important because it helps us boil our resources down into smaller bite-sized pieces that should contain coherent pieces of information. The idea is, like, say we have a Wikipedia article, right? We want to take that full Wikipedia article and then split it into like its individual headings or into its individual parts. or individual paragraphs, right? And so that's what we're going to do with LangChain today, is we're going to use this tool called the recursive character text splitter. Sounds fancy. All it does is it takes your text and it chops it first by double new line, then by new line, then by space, and then by token. So the idea here is that we're going to take our 750,000 token long document and we're going to boil it down into a number of chunks. And each of those, yeah, go ahead.
So when it does that, it's just chunking the text within
Yeah,
the book,
it's
right?
giving the tokenized version as Cypress length plus 20.
Yes.
So it's not providing.
So
No, if you go to
we're swapping?
context,
Okay.
right? If you go up a little.
We're going to swap and you guys are going to learn more about it and then we'll come back. Yeah, you bet.
Yeah,
Screen share.
Yeah, thanks, Chris. And I think we're going to probably power through some of the questions. So if you could save your questions, write them down for the end of the session. I think that'll make sure that we have time to get through all the material covered today for those of you that maybe don't have as much time tomorrow. So what we're sort of, where we are with this is we talked about models, we talked about prompts, we talked about chains, and now we need to talk about indexes. And this is the best meme because the answer is yes. And it's not that crazy. And that's sort of the point of today. Pinecone's not that crazy. None of this stuff is that crazy. So we are putting the R in RAG, as Chris alluded to. Now, let's go back to our framework here. The R is this dense vector retrieval. So let's break this down. First, dense vector, then retrieval. And I want you guys to sort of recall back classic NLP status, right? You've got text that you turn into numbers. You do this through tokenization and then embedding. And this is the best, right? Quiz, everybody. Quiz time. Okay, so where should we put apple? I know you guys are at a pretty advanced level, so this might be C. Nailed it. Apples and bananas, right? Okay. How about this one? Where should we put cow here?
B.
A.
Oh.
C? B?
Oh, A.
A or B? C. Oh, wow. Yeah. Okay. Well, why? Oh, my God. Well, puppy is to dog as calf is to cow. Puppy is to calf as dog is to cow. So we can see this. This is sort of like, I don't know, like age or something, right? And this is maybe like size or, But then it's like, where does the AV guy fit on here exactly? Or like, where does the Renaissance itself fit on here? Or where does MLOps world fit on this, right? Gosh, yeah, I don't know, age versus size, right? It's not enough dimensions, right? And that's what we're talking about when we're talking about embeddings. We're talking about we need to create this thing that represent these words in enough dimensions that we can talk about how they're differentiable from one another. If you talk to Cohere, that you might use a 4096 dimensional vector. And these vectors, when you have that many, and all the numbers are not 0, are called dense vectors, right? And this idea of dense vectors and dense vector representations has been shown for the last 10 years, ever since the absolute classic Word2Vec. What a classic. If you haven't seen the illustrated Word2Vec, king minus man plus woman equals queen. So good. So good-ish, right? This was the first thing. They wrote this 10 years ago. They said Word2Vec is really, really good because it's been proven to be very good on a number of downstream tasks. Man, that has aged well, downstream tasks. That is what LLMs are all about, is downstream tasks. And so we're using LLMs not to do LLM things. We're using them to do downstream, much, much simpler tasks. This is the whole point. Word2Vec, iconic dense vector representation. Okay, but what about that new? Well, now it's like this is the good stuff, right? OpenAI's ADA embeddings. If you know, you know. It's not OpenAI GPT, it's OpenAI ADA embeddings model. That's the gold standard, full stop, that's it. But if you can never put your data into there, ruh-roh, then it's no good for you. I can't let OpenAI see my data. I can't let them train on my stuff. So maybe I'll go to Hugging Face. Maybe I'll go to the massive text embedding leaderboard and pick out a nice open source embedding that can solve my problem. And in fact, that's what we're going to do today. What are we going to pick out? Well, you'll see soon. But let's put the R actually in RAG for realsies now. We got the dense vector. We're ready for retrieval. What is retrieval? Well, Chris started talking about it. And 3 simple steps to retrieval. Ask a question, search a database for stuff that's similar to the question, similar, as we've already talked about, how it's measured, and return that stuff. So we need a database for that. The database that we use is called an index. And the index is made up of documents split into chunks. This could be PDF level documents or NLP, classical sort of document language. Then we create embeddings for each chunk, run it through the embeddings model. Could be Ada, could be something else. Create all those vectors, put in a vector store index. We already talked about this, but it's sort of breaking it down point by point. Now, there are many types of indexes. And you can use retrievers for all of them. Retrievers are wrappers around indexes. Indexes can be used for qualitative, quantitative data. Forget indexes as being a crazy thing. Talk to Llama Index or come study with us on Llama Index if you want to learn more. But the most important index for you to learn about is a vector database, which is just a database. So index is sort of this meta abstraction. The retriever can wrap around any index. And so the idea is now we can ask our question, take our source docs, we put our question in our source docs through the embeddings, we got the vectors all teed up, get those cosine similar neighbors, we get our context, right? We already saw all this, we're seeing all the pieces come together. The retriever is basically doing this part. It's doing this part. So this hopefully brings it together. This is all vector stuff, right? And that's the idea, dense vector retrieval. Can we make it to the end here? The retrieval and the retriever, the retrieval QA chain and LangChain, will take this stuff, we'll put it here where we need it, we'll go into the prompt template, we'll go into the LLM, we'll get our output answer. Why our tile is important, immense psychological value, et cetera, et cetera. So dense vector retrieval happens down here. In-context learning happens up there. We're putting stuff into the context window so that it learns, and then we get our answer. And with that, we've put the R in RAG, and I'm going to highly encourage Chris not to take many questions as he continues through the notebook, because it is a legendary notebook, and I'd like us to get through as much of it as possible. bit.ly/aimrag to follow along for yourself. And we'll come back and talk about Pinecone. Oh yeah. Oh yeah.
Gotta do the Zoom screen share thing and ask if you can see my screen. So the idea here is that, again, what Greg just talked about, right? So we're gonna chunk these documents first. The idea is that we can't fit the whole series of books. We can't fit all of our company's documentation into a single prompt, right? We're gonna need to break this down. We're gonna use a fairly naive chunking strategy here, right? We're just gonna say, we're gonna break the document down into chunks of 100, based again on that pattern of double new line, space, character. And the reason we're doing this, right, is just to give our LLM a better chance to get exactly the information that it needs and not all of this excess information, as well as being able to fit it into our context window.
Is the LLM not going to lose the context if you break into, you don't know where to break, right?
We don't know where to break, but we know where to search, and that's what we're going to talk about in just a second. Yeah, but great thing. So all we got to do is split our text. Now we're going to split that original paragraph that we had earlier, just because it's an easy to follow example, right? There's not a lot of text. We can see it very cleanly. So we take the original documentation that we had about LCEL and we break it into chunks, and we get 4 chunks back. And you can see that these chunks are kind of split by their new line, double new lines, right? We have, if each of them is a bullet, it looks like we have about 1 chunk per bullet, right? And the idea is that when we're looking for context, right, we don't need all the information in the book. When we ask a Shakespeare, play about a certain character, like we don't need to know about every other character. We want to know about that character. And this is kind of how we laser focus in. So now that we have our chunks, right, so we took our original document and then we turned it into these 4 chunks. That's great. What are we going to do with those chunks? Well, this is, like Greg was saying, where dense vector search comes in. This is where the idea of embeddings comes in. We have a lot of text that you can feel free to read in the notebook that explains some of this. But the idea is that we want to have a quick way to decide if a chunk in our vector store is related to the query that our users are asking. And the way we do this is by using embeddings. We have another example which you can look at in the notebook, and we've changed the axis a little bit. But the idea is we're going to leverage what's called cosine similarity as our distance measure. We could use any distance measure you want, right? But cosine similarity is a popular one. It tells us how closely related 2 vectors are, and so we can use that to determine how semantically related 2 pieces of text are if we have both of those pieces of text's vector representations. We're going to leverage something called BAAI BGE base ENV 1.5. It's an embedding model. That's all it means. It converts text passages into dense vectors. So we get a vector representation of our text. And as long as we're using the same embedding model for all of our text, we can be sure that they're being put into the same embedded space, and we can compare them to each other. So let's load this thing up in LangChain. You'll notice that we're just using Hugging Face embeddings from the LangChain library. We pass in the model that we want's name, and that's it, right? That's the beauty of LangChain in its 1-year journey, is that a lot of this is very straightforward to implement in actual code. So we get our embeddings model, which is a Hugging Face embedding model, and it's specifically this one we talked about. The way that we selected this model is we went to the MTab, we went to the leaderboard, we saw the best performing one for our task, which is retrieval, and then we chose it based on size as well. We wanted a smaller one because it's for the demo, and that was it. We just chose the best performing smaller embedding model because we know that it's going to perform at least decently on our task. What's going on? Yep.
How should we use embedding model for the text? Is the same embedding model in which the model was trained on?
No, it does not have to be. That's a great question. I'm not going to spend too much time on it because I know we're strapped for time, but that's a great question. We can follow up later. But it doesn't have to be, is the idea. So we'll do the thing, right? We have puppy and dog. Let's see how related those vectors are. They're pretty related, right? One is very related. 0 is not related. -1 is not, oppositely related. So we see that puppy and dog are close. That makes sense. What about puppy and ice cube? Less related to each other than puppy and dog. There you go. That's the idea, right? We're able to determine how semantically related 2 things are by comparing their vectors. Huge. So what do we have to do then, right? Well, we have to embed every chunk that we have in our corpus. We have to put it all into that dense vector representation so that we can compare against each other. So we do that here. All we're going to do is, for each chunk in our chunks, we're going to add a dictionary key and value, which is going to be our text chunk, and its embedding. That's it. There you go, right? We don't need to do more. You can see at the end of this, we have a dictionary which has a bunch of chunks and their associated embeddings. And that's the idea of a vector store. Obviously, the vector stores you're going to use, especially the one we're going to talk about called Pinecone, they're going to be a little bit more advanced than this. They're going to have a lot more information, metadata, but for the purposes of just understanding how this is working at the heart, this is the idea of a vector store. It associates text with the dense vector representation because we can't feed the model dense vectors and have it understand as if it were natural language, right? We need that natural language, so we have to associate the two. This is great. Now, how are we going to get related chunks, right? Well, we need to embed our query into that same space and then compare our query to all of the other chunks in our vector store. The methods we use to do this in practice are much more complex and much more scalable, but the one we're seeing today is we're going to literally compare our queries embedding to every embedding in our vector store, and we're going to choose the most related one as the most related piece of text. So let's see how it works. We have can LCL help take code from the notebook to production. And we go ahead and embed it, and then we can compare it against every other item in our vector store, and we find out that the most related chunk has this idea of it's a declarative way to easily compose chains together. Sounds good. Not feeling too bad about that one. So that's great. But that's not how we interact with the system, right? We need natural language in, natural language out. So we build a retriever on top of this. And the only thing the retriever does is it will automatically embed our query for us, compare it to our vectors, and then return the associated text instead of caring about the vector. And that's it. So we can add this to our pipeline, and we can build a simple RAG system, which is all it's going to do is take our context. It's going to retrieve the context based on our query and our embeddings. We're going to invoke our chain with the query and the retrieved context. And then we're going to return the query, the response, and the context. And we can ask it this question, can LCL help take from the code from the notebook to production? And we get our response. It says, yes, LCL can definitely help take code from the notebook to production. Right? We can see that the context it used is this, there are several benefits of using chains in this matter. The idea is that it can use this context that we automatically retrieved based on our query to answer our question in a way that makes sense. And that's the whole idea of RAG in one little Python function, which is dope. We're gonna quickly talk about setting up Pinecone. So if you haven't already set up Pinecone, that's totally fine. You can do so now. All you have to do is have a Pinecone account, and then you will use your API key, which you can find in the Pinecone dashboard, API keys. We're going to be using the default environment. You can copy your key, paste it into the fields that you see in the notebook, and then copy the environment and do the same. It's going to prompt you for it. If you haven't done this or don't want to do this, there's also an implementation that uses the face vector store, so you don't have to feel like you're missing out. But that's it. Once you run that cell, it's going to take about 2 to 3 minutes, and then you're going to be ready to rock. But we'll learn more about Pinecone from Greg.
What we're going to do is just following up on this diagram, make sure everything's super clear to you. If we take a look at our embedding and our LLM models, what we did is we chose 2 models from Hugging Face, one from the Massive Text Embeddings Leaderboard, that was the BGE base v1.5. This was performance versus actual ability for you guys to do it on the right GPU. And the Llama 2 7V chat from new research was mostly based on the fact that you don't have to sign up through Meta to actually use this one. And that was a sticking point in previous trainings we've done. Okay, so the open source RAG implementation with Pinecone and LangChain is what we're going to work on. And the idea here is the LLM operations stack is sort of focused around these centerpieces, these pieces of glue in the middle. LangChain, Llama Index. Haystack's coming out with their own, Elasticsearch is coming out with their own. There's new players in the space all the time. Is this just down? Is this just down? If it's down, we can just.
It's not down, I just need to be reseen.
It's been on the fritz the whole time here. It's been in and out. But, the idea is Pinecone got a lot of funding. Probably heard about them. LangChain got a decent amount of funding. Probably heard about them. That's why we're using Pinecone and LangChain, because it's like those are the hype. But we can use Facebook AI Similarity Search. That's totally fine. Totally open source. Pinecone is like, it's open source, but you have to sign up for an account. And they'll try to get your credit card from you. Because, they are a company and they're trying to do big things. But, if you want to use the coolest name thing, that's what we wanted to do today, is make sure that you guys could use that. So you don't have to use the Pinecone thing, but it adds a little something if you do, right? Put it on the old resume. Yeah, I've used Pinecone, no problem, right? 100 milli, no big deal. Yeah, I used it. But, I think the fun thing is why Pinecone, right? They have not changed easy long-term memory for high-performance AI applications. What is that? Okay, great. Okay, so you're a vector database, you're a vector store. Great. They have fast and fresh now. They're coming out with some new stuff. It's great. But it's why do we use pandas, right? It's Polar is faster, PySpark is more performant at scale, but everybody uses pandas. It's they captured the market already. And Pinecone, Chris was cracking me up earlier, it's just good. It's not great, right? It's it's good. This is what LangChain says about it. If you're looking for a production-ready vector store, you don't have to worry about hosting yourself, then go for Pinecone. But mostly, we said we were doing this, so we're doing it. All right, and that's about the state of vector stores. But it is useful, in the context of our dense vector search discussion, to think about how they do hybrid search. Chris said he did a very, very naive search. This is not naive. This is billions of vectors, and they do this sort of sparse, dense thing. So they create the dense, they create the sparse, they create an index, they upsert. I saw this, I was like, what? Update insert, right? It's oh, okay, cool. Search the index, return the vectors. And so you can see this is sort of a little bit of their dashboard, and now you guys totally get it, right? Sparse vector just means there's tons of zeros, so you can search it a lot quicker. And what we're doing is we're leveraging pods. That's one of the key things in Pinecone. Pods are essentially the way we kind of decide how performant our thing's going to be. We use P1 because it's free, and it's pretty good. So you see 768 dimensional embedding vectors, and it's pretty solid. It's good. And then, what we're doing with LangChain is we're gluing things together. We're sort of just, it's the glue. We already used some of the glue before. We're going to hold on that. But this is about gluing it all together. And now this thing is Pinecone. And that's it. And we're going to see how Chris can make this happen. If this was the whole thing, it would have been done really quickly. And the whole idea is by the end of this, you can have an entire RAG system in this many lines of code that you can just take that boilerplate code and show it off to people in the future by the end of this notebook. So Chris is going to make it happen now, and I'm going to give him a hard 10 on this, and maybe give him a 2-minute warning if we don't make it happen, so we can keep it light, keep it tight today. Thanks, everybody.
Alrighty. So we talked about LangChain a lot. We use it a little bit, right? We use it to connect our prompt or our text to the LLM. That was great. So let's actually build the RAG system with it now. And like Greg said, if this is all that we were doing today, it would be very short. You could have been already eating or whatever else. So we're going to go through it. The first thing we have to do is get some data, right? We're going to pull our data straight from the web. It's going to be a PDF, and it's going to be every Hitchhiker's Guidebook that there is. The idea is that's a lot of documents. You know, we looked at it before. It's several hundreds of thousands of tokens. So we're going to load that into LangChain using the PyMu PDF loader. All this means is it's going to load the PDF for us and move it into a format that LangChain can interact with. The whole library is about making your life easier, right? So if you have PDFs, use a PDF loader. If you have CSVs, use a CSV loader, right? That's the way you can do it, and that's going to take you very far very quickly. So we're going to just pass in the URL to our PDF into the PyMu PDF loader, and we're going to call .load, and that's going to load our documents into our docs object. Now, again, we can't have a 750,000 token thing sitting around for our prompt, so we're going to need to chunk it. We're going to use a similar chunking strategy as we saw before, but we're using 200 token long chunks, and we're going to split that one big 750,000 document into 659 little chunks. And the idea is that we want to be able to call up those small chunks that are going to be relevant to our users' queries, and that's it. So now we have 659 200-ish token long documents. We're going to go ahead and create our vector store through Pinecone. If you have set up Pinecone, this step's going to be straightforward. If not, you can use the Pinecone alternative, which is going to be Face. It's up to you what you want to use. But the idea is we're going to take our Pinecone vector store. We're going to use the from documents method, right? Makes sense. We have a bunch of split documents. Let's use from documents. We're going to pass in those split chunks. We're going to pass in our desired embedding model, which is in this case going to be that BGE base model. And then we're going to name it based on Pinecone's preference, which in this case is default, since it's the one you're going to have when you first set up Pinecone. And that's it. All of that stuff we did before, where we looped through everything, we created embeddings, and we stored it in a dict and all this stuff. I mean, it's all been done for us in this one line of code, and it's ready to be used. The only thing we have to do, just like before, is we have these vectors, we have this text, but we need a way to get text in, text out. And so we're going to apply this as retriever method to convert our index or our vector store into a retriever, which is going to behave in the way we expect. It's going to allow us to pass into it text and receive out relevant text. And that's the whole indexing process, right? That's all you got to do. Thanks, LangChain. It's doing a lot under the hood, so don't forget what's happening, right? But we don't have to see it. Next thing we're going to do is create our RAG prompt. You'll notice that this is extremely similar to the prompt that we had earlier when we were doing our naive RAG, right? It's the same thing. We just need a chat prompt template that has the capacity to have our context and our question, and then has this kind of instruction of use that context to answer our question. And then we're going to create the RAG chain, and this is where we're going to see that LCL a little bit more intensely. We have this RAG chain, and you'll notice like we just take our context and our question, and we pass it into our RAG prompt. You'll notice that the context is going to go to our retriever. So it's going to retrieve a bunch of documents, right? The default, I believe, is 3 documents. So it's going to retrieve 3 documents. That's great. Our question is this very fancy sounding runnable pass-through. All it means is it's just going to go to the next thing. It's not really going to do anything. It's just going to carry on to the next step of the chain without really doing anything. The runnable pass-through lets us trace it better, lets us understand how it's flowing through our chain, but all it's really doing is saying, you're going to the next guy. So we take our context that we've retrieved with our retriever, which is powered by our Pinecone vector index, right? That's hosted on Pinecone servers, thanks Pinecone. And we're going to pass that context plus our question into our RAG prompt. And that's going to format our RAG prompt with the context we retrieved and our user's question. Then we're going to pass that prompt that we created to our LLM, right through the chain. And you can see each step of the process is just this pipe. We pipe the response from this into our RAG prompt. Then we pipe the RAG prompt into our LLM. And then we pipe that into a string output parser, which just formats it as a string. We want that because we're going to read it. There you go, right? You don't have to include this step. You can do whatever you'd like, but this just helps us get a string back so we can print it out and look at the response. And that is the entirety of setting up a RAG chain in LangChain for real. That's all you have to do, right? Now, obviously, you can get a lot more complex than this. You can add a lot of different things to it. You can change the retriever. But this is the way to do it from like the simplest perspective. This is going to take our document and be able to answer questions about it, as we can see here. We can ask the question, what is the significance of towels in Douglas Adams' Hitchhiker's Guide? And we get this response, are incredibly useful interstellar hitchhikers items. They can serve various purposes, such as wrapping oneself for warmth, lying on while inhaling the heady sea vapors, sleeping underneath during space travel. I mean, the idea is the towels are important to the series in this way, and we see the LLM understand that and answer it. And you might say, well, what if we ask a question that probably isn't answered by Douglas Adams' Hitchhiker's Guide series? Like, what if we wanted to know the airspeed velocity of an unladen swallow, right? Well, it says, I don't know. The provided context does not contain any information about the airspeed velocity of an unladen swallow. And this is the idea behind RAG, right? Not only are we giving ourselves that specific domain information and the ability to answer questions based on our context, but we're also giving ourselves that option of, I don't know, I can't answer that question. Instead of hallucinating confidently, it doesn't. There you go.
Okay, that's why we call him the wizard, the LLM wizard. Like and subscribe, Chris Alexiuk on LinkedIn. We'll have a QR code for you at the end of the session tomorrow. So, that just about wraps us up today. We kind of did see what we mean, and this way we can break down RAG for everybody. We saw it visually as well. It's just a couple easy pieces. We're just building with Lego blocks these days with LLMs. And so in conclusion, LangChain, if you master those system, human, and AI roles, you're well on your way to understanding how to integrate proper prompt engineering into RAG systems. Hugging Face is a great tool to pick out your embedding stuff, to pick out your LLMs, to figure out what's the best. Pinecone's good. Lots of vector stores are good. That's a very, very busy space. It's very hard to differentiate. But tomorrow, what we're going to do is we're going to talk about advanced retrieval, because that's where the vector store people are differentiating. Is like, well, how good is your R in RAG exactly? And what does that mean for any given context or set of data or metadata or really complicated cool, fun stuff? We start to get into a lot more actual engineering there. And finally, I want to tell you a little bit about AI Makerspace. I'm Greg, this is Chris, and we've been teaching and learning for a while. And as a university professor for about 10 years, I saw that the only students that were really succeeding in a 21st century workforce were the ones that were like learning new skills, building something with those new skills, and then sharing that something with others. Nobody else was succeeding in the medium to long term. It just wasn't happening. You can't just know cool stuff and do nothing with it, it turns out. It was not degrees, it was not prestige, it was not anything that the universities will make you believe matters. In fact, it was making stuff with communities of other like-minded people that really mattered, and it really got people that 120, 150, 200K a year job that they really dream of. And so this is our ethos at AI Makerspace. It's build, ship, share. And as engineers, you know what ship means. Deploy that thing. Get it out of the damn notebook. And when you do, make sure you tell people about it. Don't just do it in the bargain basement of your current large corporation, because nobody's going to pay attention to you. It's all about building, shipping, and sharing. And that's what we're all about in our content online and in our courses. We did a lot of content over the past couple years with deep learning AI, with Fourth Brain, hundreds of thousands of views, many hundreds to probably 1,000 students. This is our newest endeavor with AI Makerspace. We're putting out as much content as we can muster and try to keep up with the Joneses here. If you're into Llama Index, you're into LangChain, you're into learning about the craziest, out on the edges RAG stuff, that's what we're here for. So please like and subscribe to our YouTube for free stuff. And if you're into learning with cohorts or community, that's also something that we offer, and this is how we actually generate revenue for the business. I want to tell you about this brand new course that we have called LLM Engineering for a second, while I have you as a captive audience. And we created this because everybody that was in this class told us this was what was missing. And they were like, gosh, you guys are talking about all this prompt, this the production and at scale and creating these RAG systems and doing advanced retrieval and hybrid indexing and doing it in AWS. But what's actually going on when I have to do fine tuning? I want to know more about the LLM. And so we're sort of inventing this new LLM engineering, right? How many of you are sick and tired of seeing this slide with roughly this much white space? Huh? Right? Because everybody knows what this is and what it means. The people presenting would lead you to believe, right? But does anybody really that would dare to put this slide up know what the hell is going on here? The other thing that they'll do, right, is they'll do this. And it's either this or this, but nothing betwixt or between. Why? 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 And then they'll tell you that attention is all you need. And then they leave it at that, right? Well, it turns out that when we really talked to every single student we've ever had, none of them knew what the hell was going on. And we found out, too, when we really had deep discussions as a community, we didn't really have a deep enough understanding of what was going on that we feel like we should have. It turns out almost nobody understands what the hell's going on. And that's why we built this. What if I told you that it's not just attention is all you need? It's the fact that each attention head within GPT-4, the decoder-only style model, is focused on something different. And that something different, it comes from not only all of the data it was used to be trained in the first place using semi-supervised sequence learning, but it came from fine-tuning subsequently, from additional instruction tuning and alignment, and from reinforcement learning with human feedback. And it turns out that in order to get your model to pay attention to what the hell you need it to, you need to know these things. You can't just rag your way to a better mousetrap. And so, this is a lie. We're ready to dispense with this once and for all, and we're going to start putting out content. So if you're not interested in joining us for the course, please join us next week for our November 2nd event, where we're going to try to demystify this once and for all. And we watched Zoolander as a team this week, and this seemed appropriate. If you are ready to buy, I'm actually ready to take orders right now. You can go ahead and scan this QR code and let us know that you're serious about it. If you do something for me and you take a build, ship, share sticker, a badge, if you will, because you built, shipped, and shared with us today, and you wear that thing proudly on your badge on badge, then you're damn right I'll give you a discount. Come to our booth in the startup corner, and we'll talk about it. Please take an AI Makerspace tag. We'd love to see it on your laptop. We'd love to see it on your bag. We'd love to see you around. Come talk to us. Come hang out with us tomorrow for even more advanced RAG. Thank you so much, everybody.